Hello, my dear students. So let us start discussing the questions from our test 7. So let us start with the very first question, which is indeed a very interesting question, जिसने बहुत सारे equations को various thermodynamic process की involve कर लिया है एक ही question ने. So a student is performing an experiment in the lab for which he has drawn the following cycle. There is a cycle given and it is mentioned that 4 to 1 वाला जो process है, that is adiabatic. That means Q is equal to 0, right? नाउ आपको बताया कि पूरे प्रोसेस में नेट वर्क डन कितना होगा. सो लेट अस चेक आउट. सो जब 1 से 2 गए, वॉल्यूम रिमेन्स कांस्टेंट. तो अगर वॉल्यूम कांस्टेंट है, दैट इज आइसोकोरिक प्रोसेस. अगर वॉल्यूम में कोई चेंज नहीं आया है, वॉल्यूम कांस्टेंट है, तो वर्क डन इज 0. सो 1 से 2 जाने में जो वर्क डन है, दैट इज 0. नाउ 2 to 3 प्रोसेस में क्या कांस्टेंट रह रहा है आप देख रहे हैं ग्राफ में, टेम्परेचर. दैट मींस इट इज आइसोथर्मल प्रोसेस, राइट? फॉर आइसोथर्मल प्रोसेस वर्क डन इज, आई होप यू ऑल नो, वर्क डन इज माइनस एन आर टी एल एन ऑफ V2 बाय V1. तो वो जो वर्क डन का फॉर्मूला होता है isothermal process का, that is given here, right? So work done in the isothermal process is minus nRT log of V2 by V1. तो आप देख सकते हो फाइनल वॉल्यूम जो है वो V3 हो गया है, इनिशियल वॉल्यूम इज V2, so you can get your answer from here. And 3 to 4 वाला जो प्रोसेस है, जहां पर आप देख रहे हो जो प्रेशर है दैट इज कांस्टेंट. सो अगर प्रेशर कांस्टेंट है, वो क्या हो गया बच्चों, हमारा आइसोबारिक प्रोसेस. तो आइसोबारिक प्रोसेस का जो वर्क डन होगा, P डेल्टा V माइनस P डेल्टा V, दैट इज माइनस NR डेल्टा T. तो यहां पर आया माइनस NR डेल्टा T. और ये जो एडियाबैटिक प्रोसेस है, एडियाबैटिक प्रोसेस का भी वर्क डन, आई होप यू ऑल नो, NR delta T by gamma minus 1, right? So gamma minus 1, gamma is Cp by Cv. तो ये सारी वैल्यूज पुट करोगे एक क्वेश्चन जिसमें सारे एक्सप्रेशन, चारों प्रोसेस, आइसोथर्मल, आइसोबारिक, आइसोकोरिक, एडियाबैटिक, सबका वर्क डन का फॉर्मूला लग रहा है. सो इफ यू नो द फाइनल एक्सप्रेशंस ऑफ ऑल दिस वर्क डन, यू कैन इजीली सॉल्व दिस क्वेश्चन एंड यू विल गेट योर आंसर एज डी. आप रीअरेंज कर लेना, एन आर आप बाहर निकाल सकते हैं. सो यू कैन सी फॉर आइसोकोरिक, so work done in 1 to 2 is 0. For isothermal, minus nRT ln of V2 by V1 रहता, final volume is V3, initial volume is V2, so you can solve it, rearrange it. And for isocoric, this is for isocoric process, isocoric process, the work done is minus nR delta T. So again you can rearrange, and this is for adiabatic. This is the work done for adiabatic process. For adiabatic process, the work done we have is, for adiabatic process is nR delta T over gamma minus 1, right? So putting all the values in these expressions, standard expression only, you will get your answer. Just add on. For each step, we'll get the net work done as this. Okay, let us move to the next question. An ideal gas is allowed to expand from 1 liter to 10 liter against a constant external pressure of 10 bar. The work done, I hope you all know the basic formula for work done is minus P delta V. Now your pressure here is 10 bar. This is 10 bar, right? And delta V is V2 minus V1, right? So it is 9. 10 minus 1, that is 9 liters. Now you are supposed to tell your answer in kilojoules, right? So kilojoules. So what you can do is convert this into pascals, that's a unit of pressure, and this liter into meter cube. Pascal into meter cube will give the standard unit, right? Pascal meter cube. So joules में you will get your answer that can be converted into kilojoules. तो आपको बस यूनिट का ध्यान रखना है, क्योंकि जो प्रेशर दिया गया है वो बार में दिया गया है, जो वॉल्यूम दिया गया है वो लीटर में दिया गया है, एंड फाइनल आंसर आपको चाहिए है किलोजूल में. और आप क्या कर सकते हो इसमें, आप ये भी कर सकते हो, इसको एटमॉस्फेयर में कन्वर्ट कर सकते हो, राइट? यू कैन कन्वर्ट दिस इनटू एटमॉस्फेयर. सो 1 liter atmosphere is equal to 101.3 joules. That also you can do the conversion. So any which way, आप कोई भी लीटर एटमॉस्फेयर से जूल में जा सकते हो, या पास्कल मीटर क्यूब से जूल में जा सकते हो किलो जूल में. दैट यू कैन डू, एंड ऑफ कोर्स your answer will be 9, right guys? Yes, so that will be the correct answer. Kilojoules, that is kilojoules. 9000 joules, that is kilojoule. Okay, now For 1 mole of an ideal gas, which of these statements must be true? तो 1 मोल आइडियल गैस है, इनमें से कौन सी स्टेटमेंट ट्रू है? U and H depends upon temperature. बिल्कुल, internal energy and enthalpy are the function of temperature. Temperature dependent है. Compressibility factor of Z is not equal to 1. आइडियल गैस है तो आइडियल गैस का कंप्रेसिबिलिटी फैक्टर Z इक्वल टू 1 रहता है, तो ये तो गलत स्टेटमेंट होगी. Cp माइनस Cv इज इक्वल टू R, ये भी बिल्कुल करेक्ट है. हीट कैपेसिटी एट कांस्टेंट प्रेशर माइनस हीट कैपेसिटी एट कांस्टेंट वॉल्यूम शुड बी इक्वल टू R. du is equal to ncv delta t, बिल्कुल ये भी करेक्ट है. डेल्टा यू चेंज इन इंटरनल एनर्जीज ncv delta t, एज n की वैल्यू 1 है, 1 मोल गैस की बात की गई है, वी कैन राइट du is equal to cv dt. so of course we'll mark our answer as A. सेकंड को छोड़ के बाकी सारे स्टेटमेंट्स आर करेक्ट. नाउ लेट्स मूव ऑन टू दिस क्वेश्चन. Consider a reversible isothermal expansion of ideal gas in a closed system at two different temperature T1 and T2. T2 is greater than T1. The correct graphical depiction of the dependence of work done on the final volume V is. Yes, so there are graphs given to us, work done and ln V. So you know, for isothermal expansion of a gas, work done is equal to minus nRT ln of V2, that is the final volume, over V1, right? So I can also write it as minus, as it is mod of work done, I'll write it simply as nRT ln of V2 by V1, and I can write it as nRT ln of V2 minus nRT ln of V1. Now it is given the V is, of course, V1 is greater than 1. So this value is, of course, a positive value, ln V1. So now we have a graph between mod of W and ln V, right? So I'll compare this equation with y is equal to mx plus c, right guys? Mx plus c. So this is my slope here. This is my intercept here, guys. Yep. So you can see, more is the value of t, more will be the slope. More is the value of t, more negative will be the intercept. t की वैल्यू जितनी ज्यादा हो गई उतनी ज्यादा जो है हमारी स्लोप भी आएगी और उतना उसका जो इंटरसेप्ट है वो नेगेटिव होगा. तो लेट्स चेक आउट क्या हमारा आंसर हो सकता है. दैट इज दिस, फॉर T2 more slope and the intercept is more negative, right? Yes, and it is already given that T2 is greater than T1. तो ज्यादा टेम्परेचर है, राइट? ऑफ कोर्स वो T2 है, T1 से इक्वेशन में मेंशन किया गया है. सो विल मार्क आवर आंसर एज बी, गाइस. गॉट इट? सो विल मार्क आवर आंसर एज बी. Now the next question is, work done in reversible adiabatic process by an ideal gas is given by. So direct question, reversible adiabatic process, the work done is given by Q is 0. Yes, so W as per the first law of thermodynamics, क्योंकि adiabatic process है, delta U is equal to W. So I can write it as W is equal to NCV delta T. Yes. So I can also replace it as NR gamma minus 1 delta T can be written as T1 T2 minus T1. So this is the formula for work done for adiabatic reversible process. So we'll mark our answer as B, right? The expression for adiabatic reversible process. Now the question is, in a figure A and B, there are two adiabatic curves for two different gases, then A and B corresponds to. So A and B corresponds to. So we have hydrogen, helium, argon. So in the options, we have helium and argon as a monatomic gas. Monatomic gas, right? And we have O2 and H2 as a diatomic gas. Right? Now, here we can see, guys. Yes. For monoatomic gas, gamma is more, right? that is more. Gamma is more for monatomic gas as compared to diatomic. Gamma is Cp by Cv. For monatomic gas, gamma is more. So now look at the graphs, guys. The one with more slope, the more gamma means more slope, will be monatomic and the another will be diatomic. So out of these two, the one with more slope, gamma represents the slope, right? So more slope, that will be for monatomic and another will be for diatomic. So A is for the monatomic gas, anyone out of helium and argon, and B can be for diatomic gas, O2 or H2. Let's figure out which are the correct option. So of course B is the correct answer. So for diatomic, monatomic, gamma is different, right? More slope, more gamma. So that is the answer, guys. Okay. 10 mole of an ideal gas is heated at constant pressure of 1 atmosphere for 27 degrees Celsius to 127 degrees Celsius. It's if CV is given in terms of temperature, then delta H for the process is. So delta H, guys, is delta H, if I say, is NCP delta T, right? NCP delta T. So I can write delta H is N 10 moles from 27 degrees Celsius to 127 degrees Celsius. So the temperatures are given 27 degrees Celsius. Now you're supposed to calculate, convert it into Kelvin, guys, right? You're supposed to convert it into Kelvin only, because the temperature you are supposed to take in Kelvin, right? So 27 degrees Celsius means 300 Kelvin, 127 degrees Celsius means 400 Kelvin. So I'll put the values as 300 Kelvin to 400 Kelvin, right, guys? Same here. Cp I can write as Cv. Cp minus Cv is equal to R. The difference between Cp and Cv is equal to R. Now we are provided with Cv, right? So I will write Cp as Cv plus R. You know the expression of Cv here. This is the expression of Cv in terms of temperature. R values, you know, 8.314 joule per Kelvin per mole. So by integrating within the limit 300 Kelvin to 400 Kelvin, you will get your answer for delta H, guys. Simply, right? Just integrate it and you will get your answer as 31814 joules. Got it? That is C. You can see here, guys. So delta H is NCP delta T. Got it, guys? Okay. Now, which of the following statements is not correct in thermodynamic changes? Not correct. They are asking the incorrect one. Delta U is 0 for isothermal reversible expansion. Definitely isothermal process, temperature constant. Delta U is 0. W is equal to nRT ln of V2 by V1. No, it is minus nRT ln of V2 by V1 for isothermal reversible expansion of gas. So the C option is the correct expression instead of B. And for a system of constant volume, heat involved is directly changes to internal energy. As the volume is constant, no change in volume, work done is 0. That means whatever heat you are supplying, वो सारी के सारी कहाँ use हो रही है? System की internal energy change करने में. तो बिल्कुल, तो A, C and D correct है, और जो हमारा incorrect है, that is B answer, right, guys? So that is the B part. So you'll mark your answer as B. Which of the following statements are correct? Now the question पूछ रहा है कि इनमें से कौन से statement correct है? Let's check quickly. The expansion work for a gas into vacuum is equal to 0. Free expansion है, work done of course 0 है, कोई external force नहीं है रोकने के लिए. Okay, 1 mole of a gas occupying 3 liter of volume expanding to 50 liter at a constant pressure of 1 atmosphere. So यहाँ पर आपको simply P delta V लगा के work done निकालना है और check करना है कि क्या answer correct आ रहा है. So here we will write W is equal to minus P external, that is one delta V. Delta V is V2 minus V1, that is 12 liter atmosphere है. 1 liter atmosphere is equal to 101.3. 1 liter atmosphere है, आपको उसको convert करना है joules में, so that you can verify your answer. Right, guys? Yes, so without sign they are asking. So you have your answer as 12 liter atmosphere, just converted into joules. Of course, you will get your answer as this only. This is correct. This is correct. The maximum work done during expansion of 16 grams of O2 at 300 Kelvin from 500 decimeter cube to 25 decimeter cube. The maximum work done during the expansion of 16 at from this maximum work done. Yes, guys. So here also you are supposed to calculate the maximum work done, right? So the maximum work done you are supposed to calculate here. In C option, it is somehow some misprinting is there. There has to be a complete statement, the work done expression, right? So it is basically isothermal expression. You are supposed to put the value of isothermal expression. The isothermal temperature means constant energy cannot, temperature is constant, energy cannot be changed. So that you are supposed to check. For isothermal expression, you are supposed to check here. W is equal to minus nRT ln of V2 by V1 या फॉर्मूला लगाएंगे आपको मोल्स आप कैलकुलेट कर सकते हो 16 ग्राम्स ऑफ O2 है टेम्परेचर आपको दिया है कांस्टेंट टेम्परेचर आइसोथर्मल एक्सपेंशन है V2 V1 दिया है सो यू कैन कैलकुलेट सो जब आपको क्वेश्चन आया होगा तो डेफिनेटली वहां पर वैल्यू थी दैट यू कैन चेक एंड वेरीफाई यूजिंग द स्टैंडर्ड इक्वेशन वर्क डन की जो आइसोथर्मल रिवर्सिबल प्रोसेस की होती है डेल्टा एस फॉर solid to liquid is very small in comparison to liquid to gas. Of course, जब liquid से gas में change आता है, liquid से gas बनता है तो randomness, entropy ज्यादा बढ़ती है as compared to जब solid से liquid होता है. This is of course correct. And delta S is 2.303 nRT log of V2 by V1 at constant temperature. Of course, this is entropy change of an ideal gas at constant temperature. तो ये सभी statements correct होंगी. C में there is a value given isothermal expansion की here that is missing in the question. So do check out all the values that is given in C option, that is also true. So we'll mark our answer as B. Right, guys? Now we have a question. A gas absorbs 200 joules heat and undergoes simultaneous expansion against a constant external pressure of 10 to the power 5 Pascal. The volume changes from 4 liter to 5 liter. The change in the internal energy is. So, of course, delta U you are supposed to calculate. Delta U, first law of thermodynamics, Q plus W. So, Q is given as plus 200 joules, right? And there is a simultaneous expansion work P delta V minus P delta V. There is a pressure given to you. There is a V2 minus V1, 1 liter. Just take care of the unit, guys. So you have pascals, you have liter, just convert it into joules, right? Before, adding to Q, just convert it into joules because you need your final answer in joules. Take care of the units, liter, atmosphere and joule relation, right? So just be careful how you are dealing with the units here. Otherwise, it is pretty simple, direct, based on first law of thermodynamics. Right, guys? So this you can see here 1 atmosphere, because 10 to the power 5 Pascal is approximately 1 atmosphere. You have liter atmosphere. 1 liter atmosphere is equal to 101.3 joules. So just putting the value, you'll get your answer. Right? Okay. Now the question is graph for the specific heat at constant volume for a monatomic gas. Okay. So CV graph versus T graph for, of course, monatomic it is 3/2R. Of course, direct answer अपन mark करेंगे यहाँ पर C 3/2R. Right? Yes, that is for your monatomic gas. Okay. Now the question is, during compression of a spring, the work done is 10 kilojoule and 2 kilojoule escape to the surrounding as heat. The internal energy change here. So what is the internal energy change here? First law of thermodynamics, delta U is equal to Q plus W. Heat is escaped, released. That means 2 kilojoule heat is released, right? And work during the compression of a spring, the work is done. Right? Yes, guys? So, I hope you know the sign convention. When heat is absorbed by the system, we'll take it as heat is absorbed by the system, positive. Heat is released by the system, negative. So, because Here heat is escaped, released, so negative sign here. Work is done by the system, negative. Work is done on the system, positive. So that is why it is a positive sign. So we'll mark our answer as 8 kilojoules. Just be cautious about the units here. Don't get confused with the physics. Chemistry में हमारा जो इंटरेस्ट होता है वो सिस्टम को लेकर होता है, तो सिस्टम और सराउंडिंग जिस परस्पेक्टिव में हम पढ़ते हैं केमिस्ट्री और फिजिक्स में थर्मो, दैट इज डिफरेंट. तो साइन कन्वेंशंस थोड़ी अलग हो जाती हैं. सो जस्ट बी केयरफुल गाइस. Okay, we have a question here. The work done in adiabatic compression of 2 moles of an ideal monatomic gas by a constant external pressure of 2 atmospheres starting from initial pressure of 1 atmosphere and initial temperature of 300 Kelvin is. So you are supposed to calculate the work done in adiabatic process. You can check here. Number of moles of gas is given to you guys. Yes, moles are given. So what all is given to us? Let us check. And number of moles given to us 2. P2 is 2 atmosphere. P1 is also given to us as 1 atmosphere. Okay, and then temperature is also given as 300 Kelvin, right? So you are supposed to calculate the work done. To calculate the work done, what you need here is N R gamma minus 1, that is T2 minus T1. For adiabatic process, this is the work done you need to calculate here, right? NCV delta T. Got it, guys? Or you can also directly, because adiabatic process is there, adiabatic compression, because it is not mentioned, it is reversible. So W is equal to Q is 0. So that is equal to delta U. I will write as NCV delta T, NCV T2 minus T1. So what I need here is T2. Because it is mentioned already, ideal monatomic gas. So CV हमें ऑलरेडी पता है, ठीक है. तो CV अपने को पता है और 2 मोल है, N की वैल्यू भी हमें पता है. T1 is already given to us as 300 Kelvin. हमें निकालना क्या है? हमें निकालना है T2. तो अब हम T2 कैसे निकालेंगे? विद द यूज ऑफ द गिवन इंफॉर्मेशन. तो ये जो सारी इंफॉर्मेशन दी है इसको यूज करके बच्चों हमें निकालना है जस्ट T2, राइट? गॉट इट? चलो, तो अब हम लिखेंगे, क्योंकि एडियाबैटिक प्रोसेस है, माइनस पी डेल्टा वी, माइनस पी डेल्टा वी, V2 माइनस V1 इज इक्वल टू N CV delta T, T2 minus T1. So this we can write work done is equal to वर्क डन जो है P डेल्टा V होता है माइनस P डेल्टा V, दैट इज इक्वल टू डेल्टा U. तो ये लिखा है मैंने वर्क डन, और ये है फॉर्मूला NCV डेल्टा T इज फॉर डेल्टा U. तो Q इज 0, तो W इज इक्वल टू डेल्टा U. ये W का एक्सप्रेशन है, ये डेल्टा U का एक्सप्रेशन है, राइट? तो यहाँ पर मुझे क्या क्या पता है, देखो जरा. मुझे पता है T1 पता है, मुझे प्रेशर पता है, V2 V1 मुझे नहीं पता. सो व्हाट आई कैन डू इज कन्वर्ट माय वॉल्यूम टू nRT by P using the ideal gas equation. Because I know the value of P1 and P2, I can convert, I can replace the volumes here, right? So volume can be replaced, guys. So just replace the volume here, put the expression nRT2 by P2 minus nRT1 by P1, and putting all the values, just T2 is left. बाकी सारी values पता होंगी. You will calculate for T2. अगर आपको T2 मिल गया है, इस एक्सप्रेशन में T2 की वैल्यू डालिए. T1 ऑलरेडी गिवन है, and this is 3/2 R. मोल्स नंबर ऑफ मोल 2 दिए हैं, तो आपको वर्क डन भी मिल जाएगा. तो पहली चीज वर्क डन का फॉर्मूला, उसके लिए आपको चाहिए T2. T2 भी आप उस एक्सप्रेशन से निकालोगे, W इज इक्वल टू डेल्टा U. W है माइनस P डेल्टा V और डेल्टा U है NCV डेल्टा T. तो थोड़ा सा समय लगेगा, हो सकता है कहीं कुछ गड़बड़ हो जाए, ध्यान ना दो, कुछ स्टेप मिस हो जाए, कुछ सिली मिस्टेक हो जाए, बट आई एम श्योर बेसिक steps को use करके you can calculate here. So T2 आएगा 420 Kelvin, guys. Just put your value as 420 Kelvin, you'll get your answer. T2 will come out to be 420 Kelvin. You can check here, guys. Got it? Yes. Okay. That's all for today. I hope आपका टेस्ट बढ़िया जाए and see you in the next discussion.